All right, AP, we're on 15.6, equilibrium constants versus the reaction quotient. Now, the very first video in 15.1, there was one thing that AP said about common misconceptions for students, and students often have problems distinguishing between K and Q. So this was right there on the very first page of the notes. 2 learning objectives that AP expects you to master. So take a minute, read it, annotate, make some notes, and when you're ready, come back to me. Q versus K. One of them, equilibrium constant, but the key part is you need equilibrium, okay? Q is something called the reaction quotient, okay? Q is any point in time but not equilibrium. Okay? So if you notice the equation, A plus B makes C and D, and notice it's still products or the reactants, okay, whether it be KC or KP or anything like that, it's still solved the same. But what is the whole point of Q? So the reaction quotient is at any point in time besides equilibrium. The point of Q is you're trying to predict the direction of the reaction to achieve equilibrium. So basically, how do you fix the reaction to get it back to equilibrium? So Q is used to determine which way the reaction is shifting. Is it going left to right or right to left? And whose concentration and pressures need to either increase, decrease to achieve equilibrium. So the point is, we're trying to get a reaction to become equilibrium, but we must have done something to make it not at equilibrium. So how do we fix it? Okay. So comparing Q and K, all right? The only point when K and Q are equal to each other is at equilibrium, okay? So when you have the same value for K and Q, you're at equilibrium, okay? If K is greater than Q, what happens is, think of the teeter-totter, okay? So think of the teeter-totter and Rodriguez's little trick with the arrow. Pretend like there's an arrow. And which way is the arrow pointing? Well, it's pointing to the right. And who's on the right side? Products. Okay? So what happens is your concentration or, sorry, we're just dealing with concentration. I was going to say the word pressure, but not yet, not yet. Concentration, your products are way too small, okay? So with your teeter-totter, if your products are way too small, then that means you have too much reactants and not enough products. Because remember, if we want equilibrium, we want a teeter-totter that is equal reactants and products. Not one side is weighing it down. So if you have too much reactants to achieve equilibrium, we need more products. So we need to shift the reaction to the right. And how do we do that? Well, we got to produce products, okay? And what's the point of the shift? Is we're trying to get K equals Q. So let's make some notes here, okay? Forming products, that's how I'm going to make it happen, okay? How to achieve equilibrium, okay? How do I do it in the reaction? And that's the big part, is why are we doing this? What's the point, okay? So we are always trying to get Q to equal K. We are always trying to get back to equilibrium, okay? Well, on the flip side, if your K is less than Q, so notice which way your little cool arrow is pointing. I'm pointing now to the left side of the equation, and who's on the left side? Well, my reactants, okay? So according to my teeter-totter, I don't have enough reactants. So my reactants are kind of like floating in the air. My products are kind of ganging up on my reactants. I got too much. So what way do I need to shift? Well, I need to shift by making more reactants. And because the reactants are on the left side of the arrow, and so that way I can get Q to equal K. All right. Now, Rodriguez's little trick. When you're comparing K versus Q, put it in ABC order. Don't put the Q first and then the K. My little trick doesn't work that way. So when you're comparing and doing your little cool little arrow, make sure you put the K first and then the Q. Okay? But how did this get screwed up? Okay? And I put my little tricks right here too. Okay? Is because what happens is you did something to the reaction. Okay? So calculating K and Q, the cool part is it's the same way that you calculate K. Products over the reactants. Okay? Only gases and aqueous. Okay? Why no solids and liquids? Because their concentrations stay constant. Okay? So the point of Q, students don't know when to solve for Q or when are you looking at Q, is that when AP asks you about predict a direction to achieve equilibrium. Well, if you're predicting the direction to achieve equilibrium, then that means currently you're not at equilibrium. Okay, you're at any point in time but equilibrium. And I know you see those double arrows in your balance equation. Okay, doesn't mean anything. Okay, just means this is an equilibrium equation, but doesn't mean you are currently at equilibrium. So let's do an example so you can see. At this temperature, all right, so temperature is constant, and I have my equilibrium constant, Kc, is 50.5. So I actually know the equilibrium constant. Predict which direction. So that means I need to solve for Q, because I need to see, do I have too much reactants or do I have too much products? Okay. So if I have the following to proceed to reach equilibrium, if you start with this many moles of each chemical, remember we can't use moles, we need molarity, but they did tell us 2 liters. So we're going to take each one of these, let's bust out those calculators, and we're going to get each one of these into molarity. Okay, so I'm going to take, all right, that 2.0 to the E negative 2, and we're going to divide by 2, and it looks like we're going to keep 2 sig figs. So I'm going to get right here 0.010 molarity. Now, if you want to put it in scientific notation, you can, 1.0, and because you got to move the decimal 2 places for scientific notation, to the negative 2. Okay, either one is fine. We're going to take this 1.0 E negative 2 and divide it by 2. And I'm going to keep it not in scientific notation. Okay, if I don't have to, then I don't use it. And then that 3 divided by 2, probably going to get about 1.5. So I'm going to get 0.015 molarity. Okay, so I have my molarities. So now I'm going to say QC because it's for concentration. I got to list my expression first. So my HI, and remember, we have that too, so we got to square. And we do have all gases. So H2 and I2. Okay, so my HI is this value right here. So I'm going to put the chemicals in back of it. Oops, not HCl. HI, and this is H2, and this is I2. That way you can keep track. All right, my HI, 0.010. And just like K, there's no point to put molarity because the molarities don't mean anything because there's no units in this answer. H2, 0.0050, and I2, 0.015. Okay, I'm going to tackle the numerator first, 0.01, and we're going to square it. And then remember, you have two numbers on the bottom, so you have to divide by 0.0050 and then divide again because both values are in the denominator. I only need 2 sig figs, so I have 1.3. Okay? Now, I'm not going to box that because it asked me to predict. So what do I know? K versus Q. My K is 15.5, but my Q is 1.3. My K is beyond greater than that Q. Okay? So remember our cool little trick. Okay? All right? That means my reaction has got to produce more products. And my products are on the right side. So who do I have too much of? Well, if I got to shift to the product side, and the product side needs help, that means my reactants are ganging up on my products because I need to shift to the right to produce more products. And let's double check up here. So if my K is greater than my Q, K is greater than my Q, okay, the reaction has to proceed to the right, so that way K equals Q, okay? So how do you explain this to AP? Here's your essay. First you tell them, since my K is less than Q, the reaction has too little products. You could even say the reaction has too much reactants, okay? So and we're throwing the words at them, to achieve, to reach equilibrium. Okay? The reaction must shift which way? Well, I need a shift to the right. So now that's what you have to do, but how do you do it? By producing more products. Could you say it a different way? Yeah, you could say by losing reactants. Okay, either one, just don't do both. It's overkill. And here's the point, so that Q equals K. There's your essay every time. So anytime AP wants to know which way, predict the direction to reach equilibrium, that is a ding, ding, ding. That's a Q and a K scenario. Okay? So here's my question to you. What if K and Q equal each other? What if when we solved for it, this is 1.3, what if it was actually 50.5? Well, if both values are the same, there's no shifting required. Because the reaction is at equilibrium already. Okay? No shifting required. So I want you to try some. Okay? Number 2, solve for Q. Determine the direction with each system that you need to proceed to equilibrium. And compare K versus Q. But I also want you to practice your explanations. Okay? So I left you some room to solve, and I left you room to explain. Okay? See you on the next one.